Hello, Chemistry 11. Today is the second day for the chemical naming review. Now, last day, what happened was we had focused more on the terminology of chemical naming. You should know the difference between ionic bond or a salt, a covalent bond or a molecular compound, and combining capacity or ion charge. So you should be familiar with that vocabulary. And you should remember how to do ionic naming and know the difference between a binary compound, where you have two elements combining, and polyatomic. Now, most of this should be review of Science 10 and Science 9. So that's why we're going through it fairly quickly. For covalent naming, generally it is when you are given two nonmetals. Now, generally one uses the same steps, your crisscross method or the hand holding that I showed you last day, as an ionic naming, but to indicate that you are having two nonmetals joined together and they are sharing electrons, you use prefixes to indicate the number of atoms in the compound. Now, in your Heath chemistry textbook on page 53, there's a set of prefixes that looks similar to this. All right, so hopefully you remember the prefixes. One is mono, two is di, and so on. So these ones you should be familiar with. Now, for example, let's say we have nitrogen and oxygen. Again, looking at your periodic table, you know that nitrogen, let's get that here, nitrogen has a charge of -3. Oxygen is a charge of -2. So again, if you're using the hand-holding method or something like that, so if I have nitrogen with three hands, 1, 2, 3. I'll put oxygen in a different color. Oxygen with two hands. Remember, the hands need to join up. And in this case, nitrogen has a spare hand, so we need another oxygen. And then we need another nitrogen. Okay, 1, 2, 3. And then again, it's just the hand holding and joining up. And we get our answer right here. Okay, again, if you look at this, this is very similar to what we had done before, even with polyatomics, where you had the hand holding. Now, to indicate that we have covalent compounds, remember we have to, excuse me, we have to use prefixes. So in this case, because we have two nitrogens, we go dinitrogen. And since we have three oxygens, it would be trioxide. Okay. So the prefixes indicate to us that it is generally two nonmetals joining together and they are sharing electrons. Now, some of you may be asking, why is nitrogen first and oxygen second? Could I not write trioxygen dinitride? Now, what happens is by convention, if you look at the periodic table, if we look at the relative locations, notice nitrogen is to the left of oxygen. So whichever element is further on the left or further down, that is generally written first. And so we will explain that a little bit later on. But at this point in time, if you're given two nonmetals, whichever one is further on the left or further down, that one will be written first. Okay. Now, you don't always have to use prefixes. If there's only one atom of the first element, you do not need to use a prefix. For example, CO2 is carbon dioxide. Notice we didn't put monocarbon. The reason being only one carbon, therefore no prefix. But for the second example here, nitrogen monoxide, because there's one oxygen and that is the second element, the prefix is always used. Now, notice the oxygen, the naming is changed from oxygen to oxide. So that follows the rule where we have to change the nonmetals, change in the ending. Okay. And in this case, since oxygen is considered to be the second element or the nonmetal, then it has the naming changed. The ending is changed. Now, for covalent names to formulas, don't worry about the charge, just take the name and convert the formula. So diphosphorus trinitride, so all you do here, you don't worry about the charge. Diphosphorus is P2 and trinitride is N3. Okay. Now, again, nitrogen is higher up than phosphorus, or phosphorus is further down on the periodic table. So that's why it is written first. Okay. So again, be aware. You don't need to worry about the charges when we're doing covalent naming. Okay. Now, special covalent bond. When these nonmetals are alone, not combined with any other element, they have a special formula. So the key thing is when they are alone, okay, not joined with anything. So you have hydrogen gas, oxygen gas, nitrogen, fluorine, chlorine, bromine, iodine. These all exist as molecules. Okay, so these are all considered exists as molecules. Okay. Now, an example would be like this. For example, let's say if I had carbon versus hydrogen gas. Carbon would just be C. Hydrogen gas would be H2. Okay, so please be aware that these 7 elements, 2, 4, 6, 7, okay, hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine, exist as molecules when they are standing by themselves. Okay. Now, the last thing that you should be aware of is acid base. Oh, going back to here, if I said carbon versus hydrogen gas versus hydrogen atom, this is just H. The key thing is atom. Okay. Now, in this particular case, you want to go back to when we introduced chemistry. Let me see here in the appendix, chemistry introduction. Remember here, you want to make sure you understand the difference between element that's an atom versus an element that's a molecule. So again, when we look at chemical naming, you should understand the difference between a hydrogen gas, which exists as a molecule, and hydrogen atom, which is just a single particle. Now, for acid-base naming, some of you may have had this before. Some of you, this might be new. So acids generally have hydrogens in the beginning of the formula. Okay, that is characteristic of most acids. You have hydrogen in the beginning of the formula. And what happens is for 2-element acids, you start with hydro and ends in ic, IC. Now, what do I mean by 2-element acids? That would be hydrogen with another element. The example I gave you there was HCl. That would be considered a 2-element acid. So HCl, normally back in grade 10, you would name it as hydrogen chloride if you followed the naming rules because of ionic naming rules. But when it's dissolved in water, this is called, you change it to hydrochloric acid. Now, take a look at this little phase symbol, AQ. AQ means that it is dissolved in water. So HCl, when it dissolves in water, has the characteristics of an acid. If it wasn't dissolved in water, what happens is it would have different characteristics. Okay, so if we wanted to get really technical and say HCl, we need to make sure we say it is dissolved in water. So we use the phase symbol of AQ, which means aqueous. Okay, so we could say here is aqueous, meaning dissolved in water. Okay, now you take a look at the second example that I've given you. HF is hydrogen fluoride. HFAQ, when it's dissolved in water, is hydrofluoric acid. Okay, now for polyatomic acids, what is that? That would be H plus with polyatomic. Now, it is an acid because of H plus and joined up with a polyatomic. Notice the difference here. Depending on the ending of the polyatomic, ATE is IC. If it is ITE, it's OUS. And the key thing is that there is no polyatomic, no hydro beginning. This is very key. Okay, this is key. I'll explain that in a couple of seconds. So in this case, if I were to give you an example of polyatomic acids, H2SO4 normally would be hydrogen sulfate. H2SO4, notice I put the AQ, would be sulfuric acid. Notice the ending here. So we have ATE, IC ending. So if I were to write this down, I would say look at ending. And the second example I gave you would be ITOUS. Again, what you want to do is you want to look at the ending. Okay. So chemical naming, you can glean a lot of information by taking a look at what the name is, and that gives you hints about what the chemical will be. Now, remember I said it says no hydro beginning, and that is key. What I want to do is I want to bring it down an example here. Okay, so let's say if I took an example here. So let's say if I said hydrochloric acid versus chloric acid. Now, they're both acids, so we know there's hydrogen in the beginning of the formula. But notice there is no hydro beginning here. So in this case, hydrochloric acid, I would know would be HCl. Okay, AQ. Because of the hydro beginning, it's telling me that's a 2-element acid. And in this case, chloric acid, you would have HClO3, AQ. So again, you take a look at the naming, all right? One has hydro, the other one doesn't in the formula name. So therefore, you know one is polyatomic acid, one is a 2-element acid, or what we call a binary acid. Now, hydrogen is written at the beginning of the formula because here, notice I said for polyatomics, it's H plus with a polyatomic. So H, hydrogen is acting as a metal, and that is generally written first. For bases, generally have hydroxide at the end of the formula and have normal naming, sodium hydroxide. Now, why is hydroxide at the end? Because if you look at your periodic table, OH is OH minus 1. Notice it is acting as a non-metal. So I'm just going to write here, act, and I say here, act as a non-metal. So that is why whenever you have bases, OH is written as the backside on the back because the OH has a charge of -1. It's acting as a non-metal, and that's why it is written second. All right, ladies and gentlemen, this is a review of chemical naming, and hopefully the basics of this you remember. And again, a key way to sort of help you remember it, acid-base naming or ionic or covalent, is to recognize certain patterns. Look at the name. Those give you hints about what type of compound it is. All right, folks, thank you very much. Have a good day. Bye-bye.